how do we get affordable renewable energy in every neighbourhood across the land that everyone can benefit from and have some sort of ownership of? So I'm going to tell you a story about a series of energy projects that are taking place in a neighbourhood near me. We've been delivering this project called ERIC in Rosehill. It's on the outskirts of Oxford, and we're trying to crack this thing. We've been exploring localised energy grids and trying to make sure everyone can have some kind of stake in this transition to zero carbon and get our energy infrastructure in a fit state for this big journey that we have. So I'm from Bioregional, and ERIC was a project. It's called Energy Resources for Energy Resource for Integrated Communities, and this was an Innovate funded project. It was led by Moixa. Moixa are the technology lead for this project, and they produce amazingly clever batteries called Maslow's, and they've got a stand over there. As Bioregional, we were involved in bringing this project together, finding it a location, and then we were the lead on community engagement. Lots of other partners, the City Council and Green Square Housing Association. This is Bioregional. We use a One Planet Living framework. We've got a stand over there, and we work with partners to make the future possible, where we can live within environmental limits. How Project ERIC came about is a bit of a long story, but this is the UK's first and only eco-town. This is Northwest Bicester, also in Oxfordshire. It's 6,000 homes that are all planned to be true zero carbon, and this is slowly building out. This is the first phase, and so this project of many homes, true zero carbon, a large part of the strategy is a hell of a lot of PV solar arrays on every single roof, every roof that faces the right way. And that's a large part of the zero carbon formula for this project, and we got through the whole process of making it economically viable to get these PVs everywhere, and then when it came to put them in, we hit this barrier, and the national grid cannot take, on a sunny day when everyone's outside and the PVs are at peak production, we're going to fry the substation down the road. So we get hit with this massive connection bill. I don't know if there are other people here. Has anyone here hit grid constraints when they're trying to do renewables projects? Any hands up? Okay. Yeah. So we overcame it here, but we needed to find the long-term solution so that people can put as much renewables on as they can. So we started to look into battery solution. How can we cut that peak export and not have to reinforce the grid every time we try and do the right thing? So Project ERIC had three aims. The other problem that we hit at Northwest Bicester was that all these people who live in these homes with fantastic PVs on their roofs, they only get the benefit of those PVs if they are at home when the sun is shining. So if you do a typical day where you go to work during the day, you're actually getting 25-30% of the value out of your PV production. So Project ERIC wanted to address all those problems. So we want to up the self-consumption from everybody who's got PVs on their roof. We wanted to get it from 25-30% up to, say, 80% or even 100%. We want to reduce the peaks, both coming into the development and leaving. So we've got to reduce that peak export so we don't have to reinforce the grid. And we also want to give people more control over their energy so that they can run their washing machine when the sun's shining. They can be really aware and switch things off, little reminders. So that's what we were trying to do. And we found a home for an experiment with batteries in a neighbourhood on the outskirts of Oxford. It's about 1,200 people live here. It's very near to where I live, so it's very personal to me and most of my team. It's a very mixed neighbourhood. It's a good chunk of this neighbourhood is in about the 8% most deprived areas of England, so we weren't shy of really tackling the problem for who need it tackled most. Also, this was originally, a lot of the houses here were for the Cowley car plant workers. They're all post-war, so a lot of very leaky system build in this neighbourhood. And so here we have it, our virtual local grid, a schematic of Rosehill. What we got 82 homes. They all got PV on the roof, and they got a battery. They got a Moixer Maslow battery. It's about this big. It's like a large soup briefcase. It stores 2 kilowatt hours of electricity, and that was tied in with the solar panels. So most of those 82 homes were actually social housing. They were either owned by the City Council or by Green Square Housing Association. We, working with the Low Carbon Hub, we got a big PV array put on the primary school right there in that same neighbourhood. Everybody got a clever display so they can see what's happening in their home, and they had sessions with our team on how to understand what it's doing. I'll give you a close-up of the display in a minute. On the community centre, we got PVs on the roof, we got batteries in there, we got a big bank of Maslow batteries in the community centre. We managed to bring in Commonweal's Car Club, and we got their first electric vehicle here in Rosehill with a charge point outside the community centre. So all of a sudden everyone in the neighbourhood can actually have access to an electric vehicle. We can even put Maslow batteries in houses that don't have PV, because as soon as we can get to the point where the Maslows can all talk to each other, we can share the electricity. So if these guys are all out, maybe they could use the power from the PV. And we're on just a few houses, we managed to make the connection with DC LED lighting circuits, so you can save a lot in transforming from AC to DC both ways. If you stay at because the PVs produce DC electricity, and you keep it as DC, and it saves you a good 30% of your power. So that's the ecosystem we were trying to create here, all in one neighbourhood. And we had the wonderful Oxford Brookes University evaluating how well it was going, both from a technical point of view and also how was it for the people, what was the experience of having these batteries. And so they did a lot of surveying, they did deep interviews with all the residents who took part. And so obviously they collected all sorts of information about the house, about their electricity consumption. And I think the most interesting thing here is they were looking at occupancy patterns. Who's in during the day? We had some people working night shifts. Got some people who are in all day long because they're retired or for whatever reason. So that was a real key part of how this was all going to balance out. And so here's some of the insights from the Oxford Brookes work. The actual installations of the batteries by the end of the project was getting very slick. It took 2 or 3 hours. A lot of people are concerned about their energy bills. That was cross-cutting across all the homes. The PVs generated electricity more than predicted. I'm finding that everywhere I go, that PVs never fail. And the really big lesson was the electricity consumption in each home does not easily relate to how many people you've got there. People's electricity consumption habits are just everywhere. There's great big differences between people who even have the same lifestyle. So that's a hard thing to predict on a house-by-house basis. Here's a typical Eric house. You've got your PV on the roof, you've got your inverter, fuse box. So it's upstream of the fuse box is where the Maslow battery goes. So it's on the customer side of everything. So it's a customer asset, if you like, rather than a grid asset. That's really important. Here's your DC lighting and some clever controls here for the resident to use. And this is a real simple diagram showing what we're trying to achieve here. So here's your fairly typical, if you averaged out all the homes in Britain, here's your demand profile. You've got a slight morning peak and you've got an evening peak. And here's your solar production, that's your PV array. And so what we're trying to do is take that excess there, take some of the cheap electricity that comes in the middle of the night and use that to meet the peak and take the strain off the grid. This is quite a techie project, but it was also very, very much about people, and 82 individual households, all very different kinds of people. How do you make it work for them? And the other thing was we had to do all this very, very fast, like so many funding applications. The amazing city council had 3 months to do the asbestos surveys, the structural surveys, get people signed up, get the DNO signed, get the FITs registered, blah, blah, and they did it in 3 months. They were incredible. So all these people, there's the Tenants Residents Association there. This is Fran, who knew absolutely everybody in the neighbourhood, and made it all happen with the Housing Association, with Green Square. We took a lot of the Tenants Residents Association people for a spin in the electric car, first time they'd ever been in one. We did a crowd fundraiser so that we got extra batteries put in the classroom, and an LED light and a display unit so we could really tell the kids what's happening in their neighbourhood. And we built, it's a real cycling city, Oxford, even though Rosehill is at the top of a hill, but we built a bamboo trailer, we loaded it up with a Maslow battery, solar panels, and took that out to everyone in the city, got a lot of interest from other neighbourhoods. So it's a real communications project. And we had Science Oxford summer school going on, and we did loads of stuff with the kids at the school. All these kids they actually soldered their own solar panel that would charge their phone, and that's really something for them to take home. And the thing that moved me the most about this project was the brilliant idea of my colleague, because there are families there from all over the world. There are families with relatives still in Bangladesh, in Nigeria, in India and Pakistan, all over the world, where there's a real connection with some of the sharp end of what's happening with climate change and what's happening with fossil fuel extraction. And by talking that through in the classroom, people were able to make this connection that if we can generate our own renewables here, save energy here, it's actually taking the pressure off in other places. It's a big leap to make, but it made sense to people. So here's some results. This is the community as a whole. So we got a slightly smoother thing. So the blue here is consumption. So you can see a bit of a pattern. You've got your morning peak and your evening peak, morning peak, evening peak, and then it all changes on Saturdays and Sundays. This is average for all 82 households. Then this is your PV production. And where you've got a thicker line, that's the electricity that got taken from the solar production and put into the battery. And this thicker blue is where we've managed to meet some of the demand from the battery. So you can see the pattern there. And so we managed to get self-consumption from your typical 25% up to about 58% on average. Not as high as we wanted, but getting a hell of a lot more value for the residents who are taking part. We managed to get peak demand down by 8%. This is an individual house. So what you can see is if you stop averaging it and look at an individual, it's a lot more spiky. So it's really hard for a battery to respond to this kind of spikiness. Or here's kettles and different appliances going on and off. So we learned a lot about how hard it is for one little battery to really soak up those great big and very abrupt fluctuations. One of the big parts of the project, which Moixa led on, was building up the software and a platform and a display panel that would allow people to see what's happening in their home. And this is one of the results of that. And one of the massive opportunities that's coming out of it is that Moixa can start to, if they can improve the capacity of those batteries to respond, they can start to actually sell services to the grid, so that just like you've got great big national scale batteries that are soaking up excess power when the wind's blowing, or chucking out power really fast when everybody puts their kettle on in those classic peaks. if there's enough of these batteries sat on the domestic side of things, imagine thousands of these batteries all over the country, all talking to each other intelligently, we can sell grid services, and that's what will bring the price of the batteries down and suddenly make it affordable. That's the long game. So key lessons. I'm really making a pitch for community scale renewables here. It's a no-brainer, we've got to do that. And so in order to do that, you need good, strong partners, you need good engagement approaches. It's great to have independent evaluations because it keeps everybody focused on what you're really achieving, because you fall in love with the project and sometimes you can't see how it's really going. So it's great to have independent evaluations. The batteries did shift a lot of power and they did reduce that peak, and the online platforms got real potential for making a big difference in the future. So Eric's actually finished now. A lot of the batteries are still there in the homes. They've been taken over by the City Council. We're now looking to other things, so we didn't want to ignore the heat side of things. We're trying to make Rosehill a zero carbon neighbourhood, and so we did a study very much with the community. What are the options for getting renewable heat? It's very hard to do retrofit. We're trying, but retrofit's quite challenging in Rosehill. But we do have a massive Sainsbury's right there, chucking away all the heat from its coolers, and so we want enough funding from the Urban Community Energy Fund to do a bit of a study to pipe that heat in, low temperature heat network, and heat exchangers in homes. So we're just working that through. It's at feasibility study stage. And the other thing, we've got a really exciting project coming. We've teamed up with the fantastic Energy Local. Here they are. And my friend Robin is sitting here. And now Energy Local have worked out how to do this virtual grid and sharing of power in a neighbourhood, even without the batteries. Batteries are for the future, and we can do them. But actually, the electrons can be shared anyway. And so they've already trialled a brilliant system in North Wales, in Bethesda, where you've got a community that's around a hydro scheme. They've got together and formed a club, and they buy power directly from the hydro scheme. They pay slightly more than the hydro would get if they sold it to the grid, because the hydro scheme would sell it for, say, 5p to the electricity company. If the people pay 7p for a unit of electricity, then the hydro's better off, and yet the community are saving money as well. So it actually comes down to clever meters. So we need advanced smart meters to do this, and everyone needs to join the club and switch to the same energy supplier. So we want to bring this. So there's 100 people in Bethesda doing this. People are saving, on average, 24% on their electricity bills. So no batteries included. You can always add batteries to this, but it's just sharing your local resource. It suddenly means that people who don't have, say, a roof with that can take solar, supposing your house faces the wrong way, you can still join the club, and you're helping with the viability of the renewables in your neighbourhood. So what we want to do in Rosehill is move from this point where if one house puts solar panels on, about 70% of their electricity gets exported at 3p a unit. They only get the benefit of 30%. If we set up a club, all these homes can have PVs. All these homes don't have PVs, but they can join the club. And we end up with about 85% self-consumption. The PVs pay back quicker because they're selling at 6 or 10p a unit instead of 3 or 5p. So that's the new project that we're hoping to get going in the next year or so. If there's one takeaway from this, we need neighbourhood level zero carbon projects. We need to get all that. If we want to bring people along on this transition to zero carbon, we've got to do it at a neighbourhood scale as well as regional and national. So if you're working in a neighbourhood, or if you're working on a regeneration scheme, and if this sounds useful, come and talk to me, come and talk to Robin, and thanks for listening.